One thing interesting, when light is actually reflected, it gets partially polarized. More of the light is going to be with a polarization along the horizontal than the vertical. So for example, in this graphic here, we have light. This one here is showing a particular polarization, and the other one is a polarization perpendicular to the screen. The dot represents a polarization perpendicular to the screen. Now, as light shines on the surface, the refracted beam is going to have both polarizations, the arrow here and the one perpendicular to the screen. The light that's bouncing off, that's reflected, generally upon reflection for any angle is going to have more of the dots than the arrows. That's why we say it's going to be partially polarized. At a particular angle that we call the Brewster's angle, it's going to be totally polarized. So when the angle of incidence is equal to Brewster's angle, the reflected light is going to be totally polarized, 100% polarized. When does that happen? That happens when the angle between the reflected beam and the refracted beam is 90 degrees. Whenever the angle is that specific angle, 90 degrees, then light is 100% polarized. Notice here, if this is 90 degrees and this is theta sub b, the reflected angle, then our angle of refraction is just 90 minus theta sub b. Now, before going further, let's play a little bit with the simulation. Okay, here's the simulation. This is our interface. Below it we have one medium, above it is a different medium. Okay, now in red we are seeing the incident wave, and we are seeing both polarizations. One polarization up and down, and one polarization perpendicular to that. Okay, here you can see it again. Okay, now as light with that kind of polarization is hitting the interface, the refracted beam is going to have both polarizations. As you see it, if you look at the blue one. Now, however, the reflected one, look at the reflected one. For this particular angle, the reflected one has only the horizontal one. It does not have the perpendicular polarization. So that's why we are going to say that the reflected beam at that particular angle is horizontally polarized. Now that particular angle is what we call the Brewster's angle for this particular interface. Now if I have an angle smaller than that, okay, as you notice here, we have both. You notice there, look at the green, so it has both polarizations, except that the perpendicular polarization is still quite tiny compared to what you see with the refracted beam or the incident beam. Now, see there, I reduced the angle even more to demonstrate it. Okay, let's see. Okay. Now, if I increase the angle beyond Brewster's angle, we are going to get the same kind of situation. We now have both polarizations, but still the perpendicular one is a lower amplitude than the horizontal one. So it is partially polarized.